So let's start writing our code in which we will import the data, analyze it, and then predict the remaining life of these engines. So we can rename this into remaining useful life and main. In my case, it's this way. And we start importing the needed libraries. So these are going to be our basic libraries. However, later, as we will need, we will import more. In data science in particular, that is not when we're building a machine learning model or a final product version, we do tend to import different libraries, even not just on the top of the program. So import numpy as np, import pandas as pd, import seaborn as SNS. Now the pandas is for handling the CSV files, so we will import the CSV files into through pandas, and we will make data frames, and then we will manipulate the data at pandas, and later we will make these files into numpy array before we enter it into the machine learning model. But as a data scientist, we should always give a big amount of time to analyzing the data and to understand the data we are dealing with. So through this steps usually is being done. The pre-processing part and analyzing the data part is done through pandas. So this is why we import this one, this pandas. Now seaborn is just a plotting library, so it's just useful plotting library, and of course the matplotlib .pyplot for usual plotting, and shift enter. So now it's now it already imported these libraries. Now we need to import the data that we're going to basically the whole data. So for that we have to just remember that we will import this one, and which is fd001, and test fd001, and train fd001. So before that we need to name the columns, and as we import the data, we will call these columns, we will import the data with the right columns. So index, so these data actually starts by index name equals. Now here again the data starts here from this one or from the Excel sheet. We have the unit number and then time. So the first one is, we can call it unit number or just engine, make it simple. So these are the first column will be engine, the second column will be cycle or cycles, or we can also call time in cycles of and these are the index. Also we have setting names, and these are actually 3, which is operational setting 1, or we can call it setting 1, setting 2, and setting 3. And I also like to use underscore because spaces sometimes it's hard to know if there's 2 spaces, 3 or 4. Sometimes the difference is a little bit less clear. So, and this is setting 2, oh, sorry, and setting 3. So now we have setting the index and setting, and we have after these we already 1, 2, 3, 4, 5. So now 5 columns. We have the sensor measurements, and sensor measurements we already have them from this, so we can use them in tandem. Because we will need to, you can use like this. So here we go for sensor underscore names equals, and this is going to be very long one. And we keep adding as we go. So this one, we start by total temperature of inlet, or we can call it fan inlet, but we need total temperature actually. It's important. So here is the total temperature of the fan inlet, and total temperature of LPC outlet, and can also do it this way. So it's a bit kind of boring, but we have to do it. So the total inlet temperature is the inlet of the total temperature of the fan, the actual fan. The total temperature of LPC outlet is the exit of the low pressure compressors. In this engine, we have two compressors, LPC and HPC, the low pressure and the high pressure. So this is the total temperature of the LPC outlet, and the other one is the total temperature of the HPC, the high pressure compressor outlet. That one here, of course, the total temperature at LPT, low pressure turbine outlet. And we continue doing these. I think we'll need more. So this is the LPT, pressure fan inlet, pressure at fan inlet. Well, basically it's very clear. And total pressure at bypass duct. Now this one is total pressure of the bypass duct, is the duct that is the fan is going to discharge into the bypass duct, which goes around the engine. So this is the total pressure at that duct, and we have here total pressure at HPC outlet. So again, the pressure of the outlet of the high pressure compressor. Physical fan speed is basically the N1, which is the RPM of the fan, how fast is the fan rotating. Now the thing is, this is a two-spool engine. That means we have the fan, the low pressure compressor, and the low pressure turbine is rotating in the same speed. and the physical core speed means the HPC, high pressure compressor, and high pressure turbine is also rotating at the same speed. So this is just it's also important for us to understand what these values mean as much as possible, because again, like, you cannot really understand everything in these sensors, because what happens is usually in usual data we have sometimes 5,000 columns. We have sometimes more than this. The sensors just keep streaming data, so we cannot understand everything. We try to understand as much as possible of the data, but many times we don't understand everything in the data. So here, engine pressure ratio P50 over P2. Well, this is well, I think it's called, this is called usually EPER. So which is the engine pressure ratio, which is the exit pressure compared to the inlet pressure of the engine. Now, of course, where exactly is taking these measurements, like, you can read the paper that comes with this data, or you can actually investigate for some engines, but this is actually known, they call it EPER in the industry. Static pressure of HPC outlet. Now, as you can see also, like, total pressure is the pressure that is related, that is when the airflow is stopped. So if you have a stream of air and you completely stop the air, like on your hand, for example, when you get your hand outside the window, of course not an airplane but a car, you will find pressure happening on your palm. This is the total pressure, because the flow becomes zero. The speed of the flow becomes zero, and the static pressure is the pressure that you can just measure outside the car, that without stopping the car, without stopping the airflow. So static pressure HPC outlet is this one. Ratio of fuel flow PS30. I don't know what does PS30, but it seems just fuel flow ratio. So it seems the amount of fuel to the amount of flow. Corrected fan speed, I have no idea what is this, or I didn't investigate it. So, but of course I will continue, because this is what I want to show also. Part of it is I want to show that we don't need to understand all the components that we have in the sensors, but it's better to understand as much as possible. So corrected core speed, also I don't know why corrected for what. Here bypass ratio is basically, the bypass ratio is also well-known quantity, which is related with the mass flow that goes into the core, and ratio of the mass flow, or the mass flow that goes around the engine, to the mass flow that goes into the core. So a bypass ratio of 2 means there are twice the amount of air that goes around the engine into the fan and around the engine is 2 times the mass flow rate inside the engine that got burned. So sometimes, I don't know, like, depending on the engine, but a high bypass ratio will have a higher values. I think 4 is reasonable amount, but like, it seems the industry is getting more and more, the bypass ratio becoming more bigger and bigger. So you can also check now the modern engines, how much is the bypass ratio. Bleed enthalpy, I don't like bleed. Usually it's a pipe of air that goes from the engine to somewhere else, or sometimes from not sometimes, many times that we take the flow from inside the LBC or HPC, and we tunnel it to the turbines to cool them. This is to create some kind of cooling layer above the turbine, above the blade itself. Now here Also damped speed fun. I don't know what does that means, but it's okay. We continue. Damped correlated fan speed. Also, I don't know what is this. HPT coolant bleed. This is, I think, clear, which is the amount of or the, now what is the unit in here? Yeah, basically mass flow rate in pound. This is mass flow rate that goes into the HPT, and this is the mass flow rate that goes into um, the the LPT, the low pressure turbine, as a coolant to cool down the engine. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, I think is okay. So now we can call, because I know it's 26. We have all total 26. So if this is 21 and we have 5 here, it's 26 columns. So it should be 26. So this is why I counted them. Names equals, now column names, what does it equal? Will equal first the index and then the sitting names plus the sensor names. Done. And yeah, that's it. We can just run it. If you want to check, you just write it down. You can see now engine, the engine will be engine name or time in cycles, sitting one, and all of them. If you want, you can do that, but we will not do that. We'll not keep this one. It's okay, you can keep it, but data frame. Now the training data, PD, which is pandas read underscore CSV, and we put point and then slash. And what does that slash mean? We can also go now to the normal view. Now the slash is means our current working directory, and inside our current working directory again we have this name, which is camps is data. So you can take it. Of course, my working directory is not here, but it depends on your working directory. But basically, in this place, we need to take which file? Train fd01. So we take this file, but actually this is text file. So is the txt. So this is the train data. Now these data are separated by spaces. So separated equals, this is just for this data, depending on what kind of separation you have. Sometimes comma, sometimes. For this type of data, this is the data we have. Now header, we don't have header, and I will show you now. None. Names equals column names. Yeah, so why we did like this, because if you open this, of course this is, I have like a code editor, but you can see here we have no header. You can see that we have a space. For this space, this is the syntax for the space is separated by a space is we put this one. Header we don't have, and txt, because the name of the file, you can see here the name .txt, and the column names is just the one we already talked about. So we can close this. Maybe I don't think we cared, like if we didn't close it, but basically this is it. And then we shift enter, and we got it. So if we want to see the data, so this is the train data. We can see our data now, all of them like this. Yep. And it's actually 26 columns and this much 20,600 something rows. We take this one syntax again, and now we have test data. So we do the same, but this time is df test, and here it's another file, of course, is called test underscore fd01. Yep, this one, and then we shift enter. Of course, you can also see the test data, and it has 13,000 something and 26 column. And lastly, we have, of course, oh sorry, we will take the whole thing again. And the test data, in this we have, like in usual case, we actually use the train data and split it into test and train. So we take data and then split it. But in this data, he actually gave us a test data and he gave us a train data separately. So we will just use them, and he gave us the RUL. Also in usual case, we calculate the RUL and then for everything, and then split the data, and then we continue. But because we have it here, we use it. RUL ft0, all of this. Now here we have to be careful. I need to put something under here below. I still can't go up. And here we can just see that the name of the column should be, rather than this, we call it RUL, because we have only this data has only one column, which is the remaining useful life. So we just call it RUL and we run it, and we have a problem. It's name RUL. Sorry. Name equals, we have to put it in a list. So here it takes input in list, but yeah, now it's okay. We just look it again, see it, and yep, that's it.